Today's topic will be focused on square roots and cube roots. When we take notes where I do not already give you a pre-set up worksheet to fill in, you will need to take it on your own loose leaf paper, and we will take them in 2-column format. So to set up your paper, you will need to either fold it with 1/3 on the left and 2/3 on the right, or you can just freehand draw a line down there. Okay? And then across the top, you need your line for your heading. Okay? The title for this is once again Square Roots and Cube Roots. Before we start talking about the specifics of square roots and cube roots, we need to be able to do a couple of other things. The first thing we need to be able to do is graph and order real numbers. And the reason they say real numbers is because there are irrational and rational numbers in the set. When we graph these real numbers, it is always going to be on a number line. And your set of numbers is going to be out of order. So the first thing you're going to have to do is put it in order before you can attempt to graph it on that number line. Your set will always be contained in braces, and you will have many times to practice this throughout the year, so they may not look so pretty right now, but they'll get better. So our first set of numbers is the square root of 20, 4.7, 12 over 3, and 4 1/3. And don't forget to close those braces. Okay. Now with these set of numbers, before we can even put them in order or graph them on a number line, we need to convert them into decimal format so that we can better understand who's smaller and larger. So for the square root of 20, when you type it in the calculator, you roughly get about 4.47. Okay. 4.7 is also already a decimal. I like to have them equal in length, so because I have two numbers behind the 4.47, I'm going to make this 4.70. It's easy to compare them when they're the exact same length. 12 divided by 3 is just the number 4, so there's nothing special about that. For 4 1/3, it would be 4.33, and that last 3 does keep going. Okay, so now that we have the decimal conversions, we can take and do the next piece of putting them in order. And you always put them in order from least to greatest unless otherwise specified in the directions. Again, when you write them, make sure you open your braces. The smallest one in this case would be the 4. Okay, but be careful. Don't do what I just did. You don't want to put the number that you converted it to. You want to put the original number from the original set. So instead of putting 4, you want to put 12/3 because that's what it originally was. Right? And then after 12/3 would be the 4.33, which in our case was 4 1/3. Next in line would be the square root of 20. And the largest number would be the decimal 4.7, and then close your braces. So you have now put them in order. You need to take that order and now place it on a number line. For a number line, you do just that. You draw your number line, and you've got to make sure that all your decimals fit between the numbers that you want. Because ours go no lower than 4 and no higher than 5, I'm going to make it start with 4, and I'm going to make it end with 5, but in between I'm going to put other decimals along the way. I'm going to count by 0.2s, even though you're going to see my other markings on the number line. You can scale your number line however you see fit to make it work for your numbers. And it doesn't have to be perfectly equal. All right, so now that we've got our numbers on our number line, we need to place a dot everywhere that these decimals would occur. So for 4.47, here's 4.4, here's 4.5, 4.47 is about right here. And again, it is just an approximation, so get as close to it as possible. 4.7 is right here. The number 4 is obviously right here. And 4.33, here's 4.3, so it's a little bit beyond that one. So if you have 4 numbers in your set, you should also have 4 dots on your number line. Right? So remember, you're putting them in order first, and then you're graphing them on that number line. The next topic that you will have to be able to do involving square roots and other rational numbers is to be able to write repeating decimals as fractions. And we talked about this in class last time, so this should not be a surprise to you if you were listening. And I even gave you a little trick to help you remember this. Okay, so the big deal with writing any decimal that has a repeating bar over top of it is what to put in the denominator spot. So you need to make a mental reminder to yourself that you're going to put a 9 in the denominator for each digit under the line. And again, if you use this trick, it's the best thing I've got for you in terms of remembering it. Right? The 9 and the line rhyme, so it's easy to remember what number you're supposed to stick. So for instance, if I give you 0.39 and both the 3 and the 9 are under the line, then your decimal or your fraction is going to have the 3 9, and then because there's two numbers on top, you're going to put two 9s on the bottom. Now never leave your fractions this way. If you can reduce your fractions, you must always reduce them. Both of these numbers are divisible by 3, so after dividing by 3, I end up with 13 over 33. And that is a simplified fraction as low as it can go, and that is the answer that made 0.39 with the bar over it. So you'll need to practice being able to do that. Right. The next big section is where the square roots and cube roots come in. So before we actually look at some examples of how to do this, I need to fill in for you some information. We're going to label this just as simplifying roots because it's going to be both types. Right. But I need to give you some information about symbols and what you need to know about them. If you see this symbol right here, you've been using this for quite a while now, that's your square root symbol. Right? But some of you may find this one new. It looks like the square root symbol, but it has a power of 3 out in the air. That is what is known as your cube root, because anything raised to the third power is being cubed. Okay, now along with the square root and the cube root, right, we have what are known as perfect squares and perfect cubes. And later in the year, I will ask that you memorize these, but for right now, you can use your calculator to assist you. A perfect square is a number times itself, and the answer that you get is known as the perfect square. Perfect cubes are a number times itself to give you that perfect cube answer. So for our perfect squares, 0 is the smallest one we have. 0 is a perfect everything. 1 is also a perfect everything. And then after 1, we start going with 4, 9, 16, 25, 36, 49, 64, 81, 100, and it keeps going on. Okay. For perfect cubes, 0 is still a perfect cube, and so is 1. 0 and 1 are perfect everything, so you don't have to worry too much about them. But for the next one, 2 times 2 times 2 would give you 8. And then 3 times 3 times 3 would be 27, and then 64, and then 125, and 216, and the list goes on and on. Okay, so you could go from there and keep extending the list. So now that you know a little bit about perfect squares and perfect cubes, I'm going to show you some examples of what you will have to do with them in terms of evaluating and simplifying them. All right, so for our first example, if I give you the square root of 4 over 121, in your calculator, do not type in 4 divided by 121 and take the square root of the answer, or even don't type in the way it looks right now, because you're going to get a long decimal and you're not going to be able to deal with it, and you're going to think the decimal is correct. And indeed, this answer is really a fraction. So the best way to handle this one is to break it up and think of it as the square root of 4 over the square root of 121. Because both numbers are perfect squares, this fraction actually comes out being very easy to do. Square root of 4 is 2. Square root of 121 is 11. So your final answer, because it's already reduced, is the fraction 2/11. Do not give me the decimal that equates to 2/11. That would not be an acceptable answer. Okay. For the next one, if I give you the cube root of 216, in order to find the cube root button on your calculator, right, I'm going to write the buttons off to the side that you need. Go to the math button, and I showed you where that was in class. It's right under the alpha, the green alpha button, and choose number 4 because that's your cube root symbol. Then type in the number you want and hit enter. Okay, when you type in the cube root of 216, it gives you a perfectly nice answer. The answer is 6, right? And that's what is known as a perfect cube when it doesn't have any decimal attached to it. Right? But this next one that I give you, if we practice with the cube root of 180, when you type that one in using your math and number 4 button, okay, you get a long decimal. In this case, I want you to go ahead and round it off to the 10th place. If there's any rounding issues, the directions will tell you otherwise. So we're going to go ahead and stop this one at the 10th place. So your cube root of 180 is about 5.6. Okay, and the last thing you will have to do involving square roots and cube roots is estimate to the nearest whole number. Okay, which means you're going to get a decimal, but you have to round it off to the nearest whole number that it's closest to. And for most of us, we've been rounding for quite a while now, so we should be fairly proficient at it. Square root of 15, when you type it in the calculator, right, you get 3.78, da, 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 da. It's closest to the number 4. So we estimate it to be about 4. It's not exactly 4, so be careful with that equal sign. If you want to use a symbol, you want to use an approximate symbol, which is a little wavy equal sign. Okay, and then we'll do the same thing practicing with a cube root. If you type in the cube root of 80, right, you see 4 point da 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 on your calculator. Okay, when that number approximate when you round it to also be about 4. Remember with your rounding rules that if it's 5 or higher, you round up. If it's 4 or lower, you keep it the same. Right? So you will be practicing with some rounding. Right? We will do more in class talking about and practicing with these square roots and cube roots. But for now, this is what you need to know in regard to those topics.